Hello and welcome to your first lesson in advanced functions. Today we're going to be looking at dividing polynomials, and while standalone it can seem like a useless skill, I promise you that you will see the benefits very quickly once we start looking at the roots of a polynomial and the x-intercepts of a polynomial functions. First, we have an example here: 2 divided into 68, or 68 divided by 2. If you remember from your elementary school years, we were asked to see how many times does the number 2 go into 6. How many times does 2 go into 6? It goes 3 times. So what you want to do is write that 3 above the 68, because that's going to be your quotient, and you then multiply the two numbers together. 2 times 3. In that second step, once you figure it out, this is called the multiplication step. We want to multiply the two numbers and write the result right under 6. 2 times 3 is 6. We write the 6 under 6. The next one is called a subtraction step, where 6 minus 6 is 0. So we have no remainder out of the first digit or the tens column, which means we're going to lower the next digit, or the 8. We're going to repeat steps 1 to 3 all over again. How many times does 2 go into 8? Well, 2 goes into 8 4 times, right? So 2 times 4 is 8. Minus 8 is 0, and we have a remainder of 0. And I'm going to let you do the next division on your own, which is 753 divided by 22. For the first example, we have to divide a polynomial by a binomial of the form x minus b. I don't want you to concern yourselves with anything past the x value. That plus 2 is like baggage that x carries with it, and right now we're not going to concern ourselves with it. We're going to compare the x term in my binomial with the x squared term, or the leading term, in the dividend. So how many times does x go into x squared? We just compare the two of them. Well, x goes into x squared x times, because x times x is x squared. So x times x is x squared, and x times 2 is 2x. What follows the multiplication step? It's a subtraction step. So x squared minus x means 0. We have no more x squareds left. And 7x minus 2x means 5x. Now again, remember, we do not pay attention to the plus 2 at all. We only compare the x term in our binomial, or in the divisor, and the leading term in whatever is left out of our polynomial. We lower the last term in the polynomial, plus 10, and we have left 5x plus 10. So now we're going to compare x with 5x. So how many times does x go into 5x? Well, it goes 5 times. So plus 5. What follows? It's a multiplication step. Again, you're multiplying the 5 with the entire binomial, x plus 2. 5 times x is 5x. 5 times positive 2 is positive 10, or plus 10. What follows the multiplication step is the subtraction step. 5x minus 5x is 0, x, and 10 minus 10 is 0, which means the entire remainder is 0. So we can say that x plus 2 goes evenly into x squared plus 7x plus 10, and the quotient is x plus 5. How do we write that division as a fraction, right? And we're not going to care right now about restrictions. So x squared plus 7x plus 10 over x plus 2 equals, well, we found out the result, or the quotient, is x plus 5. Okay? I just want you to imagine that cross multiplication, to rewrite this in non-fraction form. So we have our polynomial x squared plus 7x plus 10 equals, well, we had x plus 5, and since we're doing the cross multiplication, it's multiplied with x plus 2. And we notice there's no remainder. So what can we say about x plus 2 in relation with our original polynomial x squared plus 7x plus 10? Well, we have a nice quotient of x plus 5, which is multiplied with the initial divisor of x plus 2, and we can say that both of them are factors of x squared plus 7x plus 10. Remember, our binomial, or our x minus b, is x plus 9. When we divide two polynomials, we're comparing leading terms. We are not looking at what comes after them. So the leading terms right now is x cubed, and in the binomial is x. So how many times does x go into x cubed? Is x squared times, because I know once I apply that multiplication step, I want to get to an x cubed. X times x squared means x cubed, and x squared times 9 means 9x squared. What follows the multiplication step is a subtraction step. X cubed minus x cubed means we got rid of the cubes, and 13x squared minus 9x squared is 4x squared. Please remember to lower all the other terms from the original polynomial, so plus 39x plus 46. And now again, we're comparing the leading term in what's left of our polynomial and the leading term in the binomial we're dividing by. How many times does x go into 4x squared? Well, I know it's going to be a 4 because there's a coefficient of 4, and I need one more x to get to x squared, so plus 4x. 4x times x plus 9. So 4x times x is 4x squared, and 4x times positive 9 is 36x. Multiplication is followed by subtraction. 4x minus 4x equals 0, so we have no x squared terms left. 39x minus 36x is 3x plus 46, because we lowered that last term. One last step and we're done with our division. Again, compare the leading term in what's left of the polynomial and the leading term in your binomial. How many times does x go into 3x? It's 3 times, so plus 3. So 3 times x is 3x, and 3 times positive 9 is positive 27. Multiplication is followed by subtraction. 3x minus 3x cancel each other out, and 46 minus 27 equals 19. Well, what happens if our divisors are of the form ax plus b, where that leading term in the binomial has a coefficient of its own? Do we change the rules, or do we perform the same type of division? In this case, we have a third degree polynomial. It's 4x cubed plus 9x minus 12 divided by the binomial 2x plus 1. 2x plus 1 divided into, right, because that's what we do, into, but what do you notice here? What's missing out of my third degree polynomial? If I'm thinking of a third degree polynomial and the order of powers into the third degree polynomial, if it's of degree 3, the next term would be degree 2, degree 1, and degree 0. Well, I have a degree 3, and it jumps over to a first degree term in that polynomial. In the division, we can't afford to skip over that second degree term. We have to put it in. However, since it's absent, how can we add it to the polynomial without changing the original polynomial? What cancels a term and it doesn't affect our polynomial? A coefficient of 0. So what I want you to do, whenever you notice something like that where the progression of degrees does not go down by 1, you have to add that extra term in. In our case, we're going to add a 0x squared plus 9x minus 12. And you're going to see in a second why we want to do that, and we can skip over it. So again, we're comparing the leading term in the dividend by the leading term in the divisor. So how many times does 2x go into 4x cubed? It's 2x squared. Now, what follows is the multiplication step. 2x squared times 2x is 4x cubed. Then if we didn't have an x squared term in the original polynomial, we just created one out of the division, and we need it to align things properly so then we don't make a mistake in the long run. Multiplication is followed by subtraction. 4x cubed minus 4x cubed cancel each other out, and 0x squared minus 2x squared is negative 2x squared. Please lower the other terms in the polynomial, so plus 9x minus 12. And again, we're comparing the leading term in the leftover polynomial by the leading term in the binomial. How many times does 2x go into negative 2x squared? Well, we notice the coefficients are the same, so I know I'm not going to have another coefficient. However, the signs are different. So there's going to be a negative, and x goes into x squared x times. Now multiplication. Negative x times 2x is negative 2x squared, and positive 1 times negative x is negative x. Multiplication is followed by subtraction, and 9x minus negative x is 9x plus x, or 10x minus 12, because we lowered that negative 12 down. Last step, comparing the leading term in the leftover polynomial with the leading term in the divisor. 2x goes into 10x 5 times, so plus 5. 5 times 2x equals 10x, and 5 times positive 1 equals 5. The 10x's cancel each other out, and negative 12 minus 5 equals negative 17. Now you see here it's asking you to identify any restrictions on the variable. What if we imagine this as a rational function? What if we would write it in the form 4x cubed plus 9x minus 12 over 2x plus 1? Well, if this would be a rational function f of x, we know we can divide by 0, and right away we would have to identify the restrictions. So I want you to go back to that grade 11 course and remind yourself, what does it mean to identify restrictions on the variable? That means that the denominator cannot be 0, and 1 is the denominator 0 at x equals negative 1 over 2. Since it is a restriction, we're going to say x cannot be negative 1/2. I have an exercise for you to try at home on your own, and it's similar to the one above. However, there is no more missing terms in a polynomial, so you don't have to make up any terms. I want you to try and divide the polynomial p of x by the divisor 2x minus 1, and of course identify any restrictions on the variable. Now let's think about the key concepts that we've learned today. So we can say that the result of the division of a polynomial p of x by a binomial of the form x minus b can be written as p of x will equal x minus b, okay, times the quotient q of x plus a remainder r. Or, if we want to write it in that fractional form to get used for rational function, we could say that p of x divided by x minus b equals the quotient q of x. However, I want you to be very careful because it doesn't equal quotient plus remainder. It's the quotient q of x plus the remainder divided by x minus b. So please be very, very careful. And to check the results of a division, you can use any of the two forms to check the results of that division.